So after partial fraction decomposition, your equation, this equation, becomes this one. So as a tip, let m be equals to m be equals to CPO over CAO. So munang natay m na variable dira because para dali lang ang integration and dili daghan ang ato ang variables na masagubang during integration. So after that, we can integrate. For this one, we will be using ln. Same goes with this. ln gihapon, this term. This one is this becomes dt. So after integrating, we'll get this equation. Negative 1 over m minus 1 ln of 1 minus xa plus 1 over m minus 1 ln of m minus xa. The limits from 0 to xa is equals to cao k times t with limits from 0 to t. And then after that, when we do, we can do or we can evaluate the limits. So after evaluating the limits, we will get this negative 1, this one for the upper limit, and for the lower limit, this one. And for the other side, this one. So ln of 1 minus 0, so we'll get ln of 1, and then ln of 1 is equals to 0. So we could cancel this because this is a 0, but this one we will be left with copy muna natin to, please. So this one becomes 0. This one left with m. This one is just g. Okay, so we could simplify this using the property of ln. So we have negative and positive. So, and we could factor this one, 1 over m minus 1. So after we do simplification of this equation, we will be getting we will get this one. And still we could simplify this again, right? Or combine. So combining this, we will be getting this. So this is now the equation that you could use, or we could transfer this to the right hand side. So we could do that. So we have 1 minus m, where m is equals to, again, that, where m is equals to, now, this one. So this is now, so muna ni siya ang ato ang working equation. This is now our working equation for irreversible bimolecular second type order reaction. Okay. So what you could do if um, you are given with um, conversion and initial concentrations, uh, no fear. Initial concentrations, CBO and CAO, and the conversion. So you could solve for the time. Or if you are given time, initial concentration, you can solve um, for the conversion. Also, if we further manipulate this, or I mean, substituting back the equation, this one, substitute na to ni siya, wherein our CB is equals to this, CBO minus CAOXA, and CA. If we further manipulate this equation becomes, so there, after further manipulation of the of this equation using this one CBO and also using this one, these two equations, we get all of these equations that we could use for this type of reaction. So these are now the equations that you can use.